Hello, my name's Dan Wilkins, and it's a great pleasure to have been invited to COSPAR 2021 to speak about how we can observe the central engines powered by supermassive black holes in active galactic nuclei, or AGN. X-ray observations are a powerful tool for studying the extreme environments around supermassive black holes and observing the material spiraling in through the accretion disk. X-rays are produced by a compact corona accelerated by magnetic fields associated with the accretion disk and with the spinning black hole, but its precise structure, the mechanism by which it's energized by the accretion flow, and how coronae are related to jets remains a mystery. But we are able to see the reflection of the coronal X-ray emission from the accretion disk, which produces a number of emission lines that are subject to Doppler shifts and gravitational redshifts that vary as a function of location, as material in the disk orbits at up to half the speed of light in the strong gravitational field around the black hole. Alongside these energy shifts, we are able to measure reverberation time lags, as the light travel time between the corona and disk means that variability in the X-ray reflection lags behind that in the primary X-ray continuum. From the reflection and reverberation of X-rays off the innermost regions of the accretion disk, a three-dimensional picture is starting to emerge of the extreme environments around black holes. This lets us map the location and structure of the corona that is producing the X-ray emission and see that the corona has two components, one associated with the inner parts of the accretion disk and a collimated core that may represent the base of a failed jet in radio-quiet AGN. We can observe the effects of strong light bending around the black hole. X-rays that are reflected from the inner parts of the disk can be bent around the black hole and returned to the disk to be reflected multiple times. This produces observable signatures that are required to explain the sample of X-ray reverberation measurements that have been made in Cepheid galaxies. And we are beginning to understand how with the next generation X-ray missions, including Athena and the proposed STROBE-X mission concept, we will be able to observe X-rays reverberating from material inside the innermost stable orbit in its final moments as it plunges into the black hole. During bright X-ray flares, we see how the corona evolves and how it can be ejected in failed jet launching events, while gaining a unique opportunity to observe the effects of general relativity. I will present the first direct observational evidence for X-rays that are reflected during a flare from the backside of the accretion disk, behind the black hole, and lensed into our line of sight in the strong gravitational field. Observations of the central engines in AGN give us important insight into the small-scale processes close to the event horizon that enable black holes to power some of the most extreme objects in our universe.